in this video we're going to look at section 6.6 using proportionality theorems. So we've talked about different theorems in the past, we've learned about proportions, now we're going to introduce a new proportionality theorems to help us solve some problems. So the first couple ones we want to look at is the triangle proportionality theorem. The first one says if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So this theorem says that as long as these two sides are parallel, these two lines are parallel, then the two individual parts that are created are proportional. So RT over TQ is equal to RU over US. Okay, so it splits it up evenly. Okay, so it is proportional. The converse just switches those statements, meaning if the two sides split are proportional, then the two lines are parallel. So if a line divides two sides of a triangle proportionally, then it is parallel to the third side. So it just says if the two sides are proportional, then the two lines are parallel. That's all it says. So they're just converses of each other. So in the diagram, QS is parallel to UT. So they're telling us those two lines are parallel. RS is 4, ST is 6, and QU is 9. What is the length of RQ? So it just tells us that these from the theorem right before that all these parts are proportional. So we're going to say X over 9 is equal to 4 over 6. And then we're just going to do some basic cross multiplication proportion work. So we have 6 times x, so 6x is equal to 4 times 9, which is 36. And we're going to divide by 6 on both sides. So x is equal to 6. And there we go. And that's it. So we just use the proportionality theorem. Because RQ represented 6, so that's all it was. On the shoe rack shown, AB is 33, so I'm going to write these in here. So AB is 33. BC is 27. CD, this is a D right there, is 44. So CD is 44. And DE is 25. Explain why the gray shelf is not parallel to the floor. So this is the converse they're talking about, meaning if it's not parallel, then they can't be proportional. So we're going to check proportionality. So it should be 27 over 33, and if it was parallel, it would be equal. So we're going to put a question mark, 44 over 25. And now to check proportionality, remember, all we have to do is do some cross multiplication. So if we cross multiply, 27 times 25, that is 675, and then 44 times 33, we have 1,452. Those are not equal, and that's why they are not parallel. So that's why the gray shelf is not parallel to the floor. Next couple of theorems. If 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally. So notice all 3 sides, all 3 of these lines are parallel. And that tells us the broken parts. So UW over WY is equal to VX over XZ. So that's all it says. It's breaking those parts up and they're proportional as long as those lines are parallel. And the next theorem, if a ray bisects an angle, so it has to bisect, that's the important part, then it divides the opposite side into segments whose lengths are proportional to the lengths of the two other sides. Meaning, AD over dB is equal to AC over CD, or excuse me, CB. So they're keeping parts together. So notice the AD and AC are both on top. DB and CB are both on the bottom. So here we go. This is the first theorem, Theorem 6.6. If in the diagram, angle 1, 2, and 3 are all congruent, and that tells us, so what that tells us right there is that we have parallel lines because they are corresponding angles. So that tells us right there, that information just tells us all these lines are parallel. That's all it tells us. So that means we can apply the Theorem 6.6. GF is 120, DE is 150, and CD is 300. Find the distance between HF and Main Street. So HF, which is Main Street and South. So we first need to find GH. And that's pretty easy. So we have so we're just say 120 over, and we're going to call this X, is equal to 150 over 300. Now, we could see a little bit of proportionality here if we could pay close attention, but we're going to still practice proportions because it should work out. So I'm going to cross multiply. So I have 150x is equal to 120 times 300, which gives us 36,000. And then we're going to divide both sides by 150. And if we do our math right, we can see 150 over 300. 150 is half of 300. So realistically, we should be X should be 240. So we're going to punch into our calculator just to double check. And we do get 240. So X is 240. So if we want to know the distance from H to F, or Main Street to South Main Street, that'd just be 240 plus 120, which gives us 360. So there we go. Now we're going to use Theorem 6.7. So right away, in the diagram, QPR is congruent to RPS. So that shows us that those two angles are congruent. That means PR is a bisector, which means we can apply Theorem 6.7. Use the given side lengths to find the length of RS. So we want to find RS. So we're going to apply it. So remember, it's QR. Now, this one's a little hard, but the whole thing, QS is 15. But if we take away RS, we're left with 15 minus X. So we have 15 minus X over RS, which is X, and that is equal to, now 15 minus X is on top, so I do the same side, 7 over, and then we got the bottom, PS, which is 13. So once again, now we just use some basic proportion work. So we're going to cross multiply. So we have 13 times 15 minus X. So we have 195 minus 13X is equal to 7 times X, which is just 7X. So then we're going to add 13X to both sides. So we get 195 equals 20x. Divide both sides by 20. So we get x is equal to 9.75. So we have x. Remember, we weren't just looking for x, we were looking for length of RS, which I guess that is what we were looking for, so 9.75.